Hey everyone, how's it going? Okay, I can hear myself, so I trust that everybody can hear me. Awesome. Yeah, thank you, Ahmed, for the introduction. I really appreciate it. I'm really happy to be here in Toronto. I've been living in San Francisco for the past few years, so it's fun to be back here in Toronto and see everybody, because this is where it all started for me. So my talk today is on developer velocity, and really an introduction to functions-first development and FaaSlang, which is an open source specification that we've developed for really function deployment, categorization, and execution. So without further ado, let's get started. So to begin with, I want to introduce myself, because it's going to give you a little bit better context on why I care about developer velocity. So like Ahmed mentioned, I'm the founder and CEO of StdLib, Toronto born and raised. I actually started programming in Visual Basic 5. There might be some groans in the audience there. Back in 1997. And I got involved with software development really because I wanted to build games, which I'm sure is actually probably the origin story for many of you here. Now, I'm an avid talker, as people who know me can attest to. I like communication. So I got really into like client-server development and architecture just when working with native applications like Visual Basic apps. I actually got suspended from high school for building a chat server and client that I distributed to students because we couldn't use MSN Messenger in class. I took that interest in like communication really to begin working in web development, mostly focused around PHP in the early 2000s, basically just hacking apart message board software, figuring out the nuts and bolts, how everything worked, really getting involved with the LAMP stack. From there, I consider myself a scientist ultimately at heart. An engineer first and foremost, but a scientist at heart as well. I did a Bachelor of Science in Biochemistry at the University of Western Ontario, which now goes by Western University, in 2010. And in 2012, I actually got myself in a little bit of trouble. So this will give a little bit of insight into me. This is me when I had less gray hair and I was probably a little bit more svelte. I made national Canadian news for for changing the title on the University of Western Ontario student election homepage to the Justin Bieber hairstyle vote 2012. It was a little bit of a prank that kind of went out of control. Friends were getting pulled out of exams and stuff, and I turned myself in. I kind of have this history of experimenting and messing around with systems, and this got me in a little bit of trouble. Luckily, it all turned out okay. I didn't end up with a criminal record. I did have to do 100 hours of community service. I helped volunteer at my high school in the IT department. From there, I went into like an actual full professional, into the profession of software engineering. Starting at Django here in Toronto, which was exited to Rubicon project. I worked there for about a year. I started in 2013. From there, based on some of the open source development I'd been doing, I became a lead engineer at a Series A funded startup called Storefront in 2014. Had a very quick stint as an API engineer at a very progressive biotech company called Synthago, founded by some early SpaceX employees. Brilliant group of people, really cool stuff. Check that company out if you get the chance to. And then, based on some more open source traction, the stuff I'd been working on, I found myself founding this company, what would become, at the time, wasn't quite StdLib, but what would become StdLib in early 2016. So the reason I'm giving that background on myself is because that whole experience with is kind of like a little miniature 15 minutes of fame, at least in the Canadian ecosystem. I kind of felt pretty remorseful for the, I mean, it impacted a lot of people in a way that I hadn't anticipated. And I kind of changed my mindset from one of like playing around and like hacking around, messing around, to really wanting to be productive. And I decided that from this point forward, if I kind of want to be known for anything, yeah, maybe it's going to take a heck of a long time. But I really want to create value for software developers, create value for people like me. So I started working around that point, late 2012, early 2013, on open sourcing a lot of this stuff I was working on. Ended up, through that process, creating a number of pretty popular open source libraries, the most popular being Nodal, an API, Rails-like API framework, the first of its kind that used like modern ES6 JavaScript syntax, and a few other libraries. The bioinformatics geek in me built a sequence alignment library in JavaScript called ntseq, which we see on the bottom left there. So that's kind of my story and how I got here. Now, my central thesis around software is that I'm really focused on developer experience, right? So my central thesis around software development, like famously Steve Ballmer on stage, developers, 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 developers. For very small gains, if you can create very small gains in developer experience, you can create massive gains in developer velocity and ability for like teams to ship code. And we've seen this pattern like over and over and over again with some of the most popular open source frameworks that exist today. And so with that in mind, and kind of my background and how I think about building software, I want to start this talk really before we get into functions as a service and FaaSlang and all this neat stuff that we're working on. I kind of want to trace a path in really the last 2 decades of software development. Like I mentioned, I started in VB in '97, so we'll start around 2000 and look at how tooling has changed. Really starting with the popularity of PHP. PHP 4 was released in 2000. That's the version of PHP I started with. The popularity of PHP and the LAMP stack, moving to consumer-grade applications like Facebook, the initial versions of Facebook built entirely on PHP, moving into 2005 and the emergence of really MVC frameworks and MVC paradigms in modern web development with the introduction of Rails and Django in 2005, as well as the introduction of Git in 2005. For many people, myself included, I don't know how I went this long without version control. This was the first version control system that we ever got introduced to. At least for myself, that was the case. In 2006, as the industry continued to mature and develop, Amazon Web Services, AWS, was introduced. Twitter was also founded in this time frame. Massively successful company, built initially on the technology that preceded it. Built on the first version is built on Ruby on Rails. To 2007, massive market opportunities around virtualization and platform as a service really allowed Heroku to grab foothold with James Lindenbaum and Adam Wiggins really driving this charge focused around developer experience. Hey, AWS exists, let's jump on this train, let's make this even easier to ship Rails applications, actually to begin with, was the focus. In 2008, we were introduced to GitHub. GitHub was founded, and social coding around Git, our workflow tools, really started to become commonplace with this increased focus on like team coordination, developer velocity. For 5 years, we had, between 2008 and 2013, really we entered like the mobile web era, and saw the rise and fall of a number of like backend as a service platforms, some platform as a service companies, one of those being .cloud, which eventually gave rise, based on their want to essentially be able to scale out for their customers faster, gave rise to Docker and really like mainstream containerization. In a very short time after Docker was released, AWS launched AWS Lambda into the market in 2014. So this is the kind of path that we're going to trace, and we're going to go over this about how we went from PHP kind of all the way to AWS Lambda and kind of connecting all the pieces there. Okay, so part 1 is really a history from PHP to functions as a service. So let's start with PHP. The LAMP stack was Linux, Apache, MySQL, PHP. For a while, I mean, some people put Python in there, some people put Perl, but it was really PHP that took over the industry, in part because PHP.NET was so accessible as a developer resource. And this was a fantastic paradigm that helped a lot of people really get introduced to web development, myself included. So what was awesome about PHP, specifically working with the LAMP stack, is PHP and the LAMP stack focused on scripts as the base shippable unit. So on your local file system, you'd have something like your www directory for your website. You'd have a messages folder and a create.php. Apache would handle all the routing for you automatically based on your directory structure. And when you uploaded that via FTP, here's, I believe that's the FileZilla client, was my FTP client of choice back in the day. So it instantly allows you to go from the local file system to map directly to an endpoint, which is, as long as you have DNS set up, mywebsite.com/messages/create.php. So what was really awesome about this is it enabled a really high degree of developer velocity, right? Because scripts were the base shippable unit, there was a really low cognitive overhead to like shipping code into production and just writing something and having it available online. In fact, this was like the rise almost of like web-based script kiddies, like people who didn't really understand what they were doing, but they could download a PHP script, upload it to a web server, and execute it. So this was actually really awesome because you could iterate very, very quickly. And this is something that's easy to grok and very tractable for software developers. Oh, I write a script, I upload it, boom, it works. Wow, the web is magic. I can create all this value in such a short amount of time. There's a hot take here from Timo that actually got me thinking about how PHP relates to the current serverless architecture, where about a month ago he tweeted, PHP was 15 to 20 years ahead of the serverless curve. You just uploaded your code, and the hosting provider took care of the rest. Now, that's only like one aspect of serverless, certainly, but it was an interesting take on the matter, because this was a really easy thing to deal with conceptually as a software developer. Now, the problems with the LAMP stack is it's not really easily horizontally replicable. There's limited resource caching, like database connections for like database connection pooling, et cetera. It would be very common in PHP scripts. In fact, one of the first piece of message board software I hacked apart envisioned power boards, a MySQL connect and a MySQL close statement at the start and end of every script. And if you missed that MySQL close, you were just going to have a really, really bad day. There were also really poorly defined developer idioms. So we made this trade-off in this ability to ship very, very quickly and like upload a script to FTP and whatnot. We also didn't create really good organizational patterns around the way that applications were built. This caused a lot of nightmares in the PHP development community in general. People started getting really frustrated, inheriting code bases from junior developers. They didn't understand how anything was working. This wasn't horizontally scalable. People were getting kind of stressed out about this, and this is where like a lot of the hate. People have opinions about language design, but this is where a lot of the hate around PHP comes from too. Like same reason a lot of people dislike front-end JavaScript is it just got massively complex very, very quickly. So from here, we were introduced to a marketing term that kind of took over the industry, this concept of Webscale. So during the early 2000s, it feels crazy to say this, like it feels like the internet's just like part of our lives and has been around forever. But really over the past 20 years, especially since the early 2000s, this is really just the start of the adoption of consumer internet. So this is growth in global internet users from 1996 to 2013 in billions. We can see from the year 2000 to the year 2004, global internet users doubled from 0.4 to 0.8 billion. So we had, and massive consumer applications started to come onto the scene, like Facebook and Twitter in the mid-2000s, that required this massive amount of scale. And in fact, any application that you built, if you started getting broad-based consumer adoption, you were dealing with more traffic than you'd ever seen before in your life, right? So these old paradigms, this concept of like, I have to have an entire operations team to like stand up racks within my startup, it started to become like very, very untenable very quickly. And not only because the number of people using the internet was growing, but actually like the time spent online grew exponentially as well, right? So I couldn't quite find data on time spent globally, but just out of China, this is total time Chinese internet users spent online per year in billions of hours. So from 2000 to 2006, it went from 8 billion hours per year to 91 billion hours. That's a 10-fold increase in a period of 6 years. So the scale that we're dealing with, the request load, is completely changing in this time frame. Startups now have more opportunity than ever before, but we need to be able to ship quickly. Giant operations teams just aren't manageable. The first place to really start tackling these issues, especially with team scale and team size, really came from actually innovations in web application development. In 2005, we were introduced to both Django and the Python web framework and Ruby on Rails. So instead of using scripts as the base shippable unit, these took advantage of application daemons, basically just a long-standing application that runs in the background. You get added value, essentially speed, decreased latency time, increased availability of your application by doing things like resource caching, and resource pooling, like database connection pooling, helped significantly, and started this widespread MVC paradigm adoption that really took over the industry. I highly doubt there's anybody here today that hasn't at least like touched Rails or Django. So then we moved from scripts as the base shippable unit to applications as the base shippable unit. And the benefits of having applications as a base shippable unit were really focused around team dynamics. Yeah, there was also benefits to scaling daemons as well. But we had added code structure, code organization. With added code organization, you got better team organization. You could actually like grow larger teams that could interface with each other more efficiently. We had strong conventions that we could teach developers quite easily, point them to a reference, slap them on the wrist if they weren't doing the right thing, and also easy virtualization of the daemons behind the scenes. So it really helped scalability, not just in the sense of like technical scalability, but also organizational complexity and organizational scalability as well. Obviously, this also created other issues. We started ending up with like gigantic teams working on monoliths and slower iteration cycles, et cetera. But that was the benefit of the application as the base shippable unit. So this really had a reliance on virtualization for scale. So we have like a diagram here of essentially a VM hardware operating system, your hypervisor that runs a guest OS on top of it, and then your application layer on top of the guest OS. So if you're a platform as a service, essentially you're scaling out your VM offering, you're standardizing your guest operating system layer, and you're just focused like Heroku, for example, you're just focused on shipping the application layer. So this is way easier to scale. This is really this is really the benefit, where AWS took over. This is easier to scale horizontally than a rack, and it's still, but it's still a heck of a lot of operational overhead. Like instead of actually having like IT people on site, if you're dealing with a platform as a service, or if you're dealing with managed systems like services like AWS, you still have to have like a developer operations team, right? So from here, we actually saw gigantic market opportunities pop up, just focused on essentially shipping Rails apps and things like Django applications, essentially with applications of the base shippable unit. We saw the emergence of GitHub in 2008 that really helped solidify and bring people together around Git workflows, which was awesome for developer velocity. There was a lot of confusion. How do I standardize? How do I share my code with people? And also we saw AWS introduced in 2006 and Heroku introduced very shortly thereafter, just being like the cloud is a thing. I think it might seem insane to some of us right now, or maybe not so much depending on how much enterprise sales you do. But people actively said there's no way this cloud is going to be a thing. Nobody's going to trust Amazon to run all their services. And now I think recently they're doing like $13 billion a year in business, AWS alone. So yeah, pretty insane growth. And Heroku had a pretty good opportunity on top of that, just focused on developer velocity. They built an entire company, sold for $262 million to Salesforce, just based on making AWS workflows even easier. So what we saw in this time frame was an increase in shippable unit complexity. So like team organization and team dynamics started to change. And because of that, we started to see decreases in iteration speed. And we saw companies pop up dealing with virtualization, dealing with sharing code, et cetera, that helped bring that iteration speed back up, right? Basically just at the company layer instead of at the tooling layer. So from here, there was, between 2008 when GitHub was introduced, there was a lot of platform as a service companies and backend as a service companies that came and went. One of the more notable ones is, as I mentioned in my timeline earlier, is called .cloud. .cloud gave rise, basically on a need to service their customers as a platform as a service, gave rise to Docker. Containers were nothing new at this point, but really Docker helped popularize containers into like the mainstream tech vocabulary. And the concept of containers, which I'm sure many of you are familiar with, is basically just removing this concept of like a VM of a hypervisor and running guest OSs and providing a single interface layer, a standardized interface layer to your base operating system on top of your hardware. So this allows you to scale applications far more easily with like far less of a footprint. Operating systems are huge, right? So you only need one OS. This is especially helpful in platform as a service environments or in like on-prem enterprise deployments. What we saw from here is in a really short time frame, from containers really being popularized and starting to take over the industry, was Amazon introduced AWS Lambda, and the very first take of really functions as a service. The idea here being you abstract away the additional redundancy and you standardize the runtime environment. So instead of thinking like, okay, hey, people want to ship whatever application they want, what if somebody just wants to run essentially some code in response to an AWS event? Well, what if we kind of tie developers' hands a little bit and say, hey, we just want to standardize the runtime environment here because we're going to be able to create so many wins on scale that we just expect you to write functions and then go from there. And that's the core concept behind AWS Lambda, and something that's been extremely valuable and is obviously skyrocketing right now in adoption. And what we've gone to here is really reintroducing this concept of a script, but it kind of boiled down even further, reintroducing functions as the base shippable unit. So in this context, you can have something like a functions folder with messages in create.js, and with a single command line command, ship that to essentially to a remote gateway that's going to direct to that function and namespace it in the same way that your folders are namespaced locally on your machine. So this is really bringing back that developer velocity paradigm that PHP introduced, but in a scalable fashion. It's like looking at the technology graph that had grown over the last 15 years and kind of saying, what do we need out of this? What are we going to take away from this? Containerization, scalability, this is awesome, but we're going to bring back this very small base shippable unit for very discrete stateless tasks. So here's an example of just like a function you can write, and when I'm saying like you're shipping a function, literally one line of Node.js, just a simple hello world function, ship this online as an infinitely scalable API endpoint very, very quickly. And this is one of the core value props of function as a service. Now, this isn't all perfect. This starts to bring back issues of yesteryear. There's a lack of resource. You can run into issues anyway with lack of resource caching between stateless requests. This can create bottlenecks like database connections and resource pooling. Databases are always a pain in our backside, far more than stateless compute for obvious reasons that you have to maintain state. However, non-blocking I/O, input-output in Node.js containers, means we can still recycle resources between network requests with certain optimizations. You shouldn't rely on this sort of thing, but these are optimizations we can make with Node.js specifically, which is pretty cool. Another benefit that we have over the last, really over 20 years ago, is compute is becoming increasingly commoditized. It's considerably less expensive to be wasteful than it was 20 years ago. Machines are also faster. Spin-up times for like application binaries are faster than they've ever been. And this trend is only going to continue, right? This is just a trend following Moore's law, which has held pretty well until now. So putting this all together, what have we really seen in this timeline if we can kind of reduce it to like a simple graph? On the y-axis here, we have shippable unit size from scripts to applications to functions and developmental cognitive overhead. Basically, the smaller the shippable unit, the less any single developer has to wait for the rest of their team to execute or understand how the full application works. You can literally give a task to somebody, we need it to do this, and we'll have another engineer integrate it into like our core API service, whatever. So you reduce cognitive overhead. And on the x-axis here, this is also like time progression, but it's something I refer to as latent scalability. So just the ability to scale your systems and scale the things you're building with zero configuration whatsoever. So this is kind of the progress we've seen. So putting this all together, now with AWS Lambda and function as a service offerings, we have a decrease in shippable unit size, a decrease in developmental cognitive overhead, which gives us really, really big wins in rapid iteration and developer velocity. So from there, I want to go to part 2, which is really looking forward towards functions-first development. How can you start using this paradigm today? Like, is it really as easy as PHP was back in the day, drag and drop a script? Yes, in many cases it is, and depending on the ecosystem you're involved with, it's rapidly approaching that. So I want to take a broad-based view of the entire ecosystem to begin with, just philosophically, about how I think and how at StdLib we think about the clouds. We view AWS, Azure, and Google Cloud as examples of system architectures of the clouds. This is touted often by people at AWS, that you wouldn't write your code, your application code in assembly, so why are you trying to stand up all of this infrastructure on your own, on-prem, et cetera? So we view AWS, Microsoft Azure, and Google Cloud is to the cloud as like Linux, Darwin, and Windows, like the base system architectures are to your standalone, to your home computer. And the reason I bring this up is because when you view the cloud kind of from this philosophy, you start really thinking up the stack, right? Like we don't develop, as has been mentioned, we don't develop in assembly anymore. We write things in JavaScript that are just in time compiled down to bytecode, et cetera. So in a new world of discrete, individually scalable remote functions, how do we standardize developer experience? How do we encourage this paradigm to become, essentially to encourage broad-based adoption? And how do we establish new programming paradigms that maximize developer velocity? Because you can, or you definitely have the potential to run into the same sort of issues you had with PHP. As we increase developer velocity, decrease cognitive overhead, we increase the ability for like new people to come into the ecosystem more than ever before, or faster than ever before, right? Another potential like Cambrian explosion of really developers and people entering the workforce. That can create some confusion if you don't establish the right development paradigms as quickly as possible. So I haven't talked too much about what we're doing at StdLib, but this is a good segue into kind of where we stand in the market. StdLib is a standard library for really like serverless application development overall. And you can think of us, I mean, really we're a public and private function as a service library, platform, and tooling to get started with essentially serverless functions as quickly as possible. The goal is, as Ahmed started with, the kind of mouthful, we enable this process of this build, deploy, discover, integrate process that developers are right now used to doing on like multiple platforms. You find open source code on GitHub. You could deploy to Heroku. You could deploy to Lambda, EC2, whatever. We make this really easy for the function as a service ecosystem. And our core value prop is within the serverless ecosystem, we're really optimized for shipping code. We want you to get from 0 to 1 as quickly as possible. So with that in mind, I mean, like, what is StdLib? Like, what's going on behind the scenes? How does this work conceptually? I mean, we have 3 developer-facing parts. This is a simplified architecture diagram, but we have 3 developer-facing components to StdLib. One is a deployment gateway that allows you to write functions with a standardized footprint and deploy it to our service. We have a service registry that has a searchable library associated with it. So if you're developing applications privately that you want to share within your organization or like a group of friends, for example, you can restrict it to only them. It's searchable in the same way like GitHub is searchable for source code and things you're trying to find. And we have an execution gateway, a standardized way of handling error responses, error codes, et cetera, optimized for serverless and function as a service execution. And behind the scenes, the gray is the non-developer facing stuff that we run internally, which is the service registry, which is kind of similar to how NPM would operate, but for actual executable functions, and function storage behind that, which is what we call to actually run your functions, et cetera. Now, this is where I'm going to start getting into FaaSlang and the innovation in open source and how you guys don't necessarily even have to use StdLib to get some of these benefits. What is function execution reliant on, and working with serverless technology? Really, as a developer, you only actually care if you're truly getting infinite scalability to your wildest dreams, then you really only actually care about 2 interfaces. It doesn't matter whether it's StdLib behind the scenes or anything else. All you care about is that you can write a function, essentially that like you used to be able to build a PHP script, and that you can push it somewhere. It just goes somewhere, and then it's easy to identify and find again and again, and that your clients, whether it's other developers, front-end developers, other back-end developers in your ecosystem, or even potential third-party clients if it's a public API, you want a standardized interface for these clients to actually interface and request your functions. So what about existing providers? Can you do this with existing providers right now? There are a bunch of awesome command line tools. There are open source frameworks that are actively working on standardizing kind of how we ship to each of these cloud providers. But each cloud provider kind of has their own opinion about how things should be run. A lot of these functions are in response to specific events on their system, so it makes sense that there's like event objects here. But do we have handlers? Do we have some sort of execution context? Some providers actually provide access to like a shim of the actual HTTP object. Do we care about that if we're executing a function? That's a little bit too much complexity. So what can we do here? Well, what if it doesn't matter who your cloud provider is? I mean, this is the concept of FaaSlang, is you can open source the intermediary. If all you care about is writing your function and having somebody be able to request it, standardization at the gateway layer in between is arguably the most important aspect of standardizing the developer experience. So this is what we've gone ahead and done with FaaSlang. So I'd like to introduce you to FaaSlang, and what FaaSlang is, function as a service language. It's an open specification that defines semantics for function as a service or serverless development, documentation, deployment, and execution. And so I'll go over each one of those points. To start off with, it's an open specification. So under the MIT license, along with some actual like working gateway code that you can run on your own in Node.js. It's at github.com/FaaSlang/FaaSlang. I'm the lead author. Our whole team works on it. Chad Fowler, who's actually one of our investors, is a divisional CTO at Microsoft and one of the original developers of Ruby Gems. So when I talked to him about a function as a service library, it jumped off the page at him. And we're actively working on this, and contributions are open literally from all over the industry, right? Now to get to development, how does FaaSlang help standardize development? Well, FaaSlang really defines semantics for named parameters and functions. I mean, the goal should be that you write a function, and the same way that you'd interface with it locally, or a very close approximation to how you'd interface with it locally, is the same way you interface with it in the cloud. So define semantics for named parameters. So for example, if you write JavaScript and have a parameter name equals world, okay, I have a default value for that parameter. I know it's probably a string type, et cetera. Provides information about the execution context, which is like an extensible definition, so different cloud providers can attach whatever they want to that context. And then a callback, if you're not writing async functions, which would just return a single value, the callback can be how you actually finish the function execution, especially in Node.js where you want to do a lot of things asynchronously. Now, from a documentation standpoint, FaaSlang introduces the concept of essentially JS doc style comments that help supplement your function to give information about how this function is run. As a heads up, I'm missing the callback parameter in the, if you notice that, I'm missing the callback parameter in the function definition there. It should be there. But the goal of this documentation enforcing is that any parameter that you specify actually in the function signature, you're able to specify documentation with it that actually self-documents your API for you. So this concept, in the same way that, that Swagger would help you document APIs today, you can now get inline documentation with your comments that not only helps, like once you ship it, helps other developers like know how to interface with this API without seeing the underlying code, but as you're developing these code bases for developers on your team that can see the underlying code, they get documentation built in right for them, and this is strongly enforced. So you cannot ship code to a FaaSlang compliant, through a FaaSlang compliant gateway if these function signatures do not match, if the function signature does not match the commented parameter definition. Now, from the deployment standpoint, like I just mentioned, there's documentation verification. So we parse function data. FaaSlang parses function data to ensure everything is documented properly, so there are no default value mismatches. So for example, if I say param number A is a number and I try and pass a string like XXX to it, even through HTTP, where everything's going to be a string in like a GET request, it'll say, hey, no, sorry, these parameters don't match. This is fully extensible. So as a specification, like we use this at StdLib, but we've open sourced this as a specification. There's no opinions as to cloud provider. So any connection can be swapped in. And feel free, by the way, like feel free to talk to me after the talk if you're interested in this and working with whatever cloud providers or on-prem solutions that you have. Happy to talk about it. From the execution standpoint, we have a standardized protocol for execution. So all functions are invoked the exact same way. This isn't necessarily HTTP specific or like restricted to HTTP, but these rules are included in the FaaSlang specification. If you are invoking functions over HTTP, this is how you should handle these codes. These are the like error codes and responses you should give. We also have built-in type safety mechanisms. Like I was talking, passing a string when it should be a number. Client errors or invalid parameters are rejected immediately. So there's no issue of like waiting for something to process and having your developers write in the code, or you yourself as a developer, oh, if this is a number, throw an error. FaaSlang handles this automatically. It's essentially like a type safety at the gateway layer instead of at the runtime layer. And also server errors, invalid returns are caught and rejected. This is especially important if you have a backend developer who maybe ships code with like an error, and your front-end developers see in the function signature, this is always supposed to return a string. This makes sure you have peace of mind from like front-end developers, other developers integrating with your functions and APIs, that they never get the wrong data type. They always get the data type that they expect, so invalid returns are caught and rejected. The function will still execute, but at the end of the day, the developer will just get an error code saying, we didn't get the response we expected. So you can catch that and fix that immediately, just checking through your error logs, right? Another great thing about execution through a standardized protocol is that we've built SDKs to interface with FaaSlang compliant gateways, and they're built and maintained in Node.js, Ruby, and Python. So this is on our GitHub repository, StdLib, libnode, libruby, and libpython. These are literally the lib libraries on all three of these package managers. So it's npm.js.com/packages/lib. It's lib on Ruby gems, and it's lib on Python package index as well. So a standardized interface that makes it feel, when you're executing and working with these functions, like they're just native functions. You don't have to build your own HTTP request from scratch, which especially in Node.js, if you've done that, request is a terrible library, and building HTTP requests is even more of a nightmare. So we've enabled these libraries for anybody to be able to interface with this. From a type safety standpoint, we basically have just used a superset of JSON standards, basically just to add the buffer type, which is raw byte data, essentially representing a file, as well as distinction between an integer and a float. Float is just an alias for number, and integer just goes through JavaScript min and max values, so you can always make sure you have a stable integer value. And then, of course, the any type. If you're not quite sure, you want multiple different input types for a single variable. Okay, so from there, cool, FaaSlang. How do I get started with FaaSlang? Well, You can get started with FaaSlang. The easiest way to get started with FaaSlang at this point is obviously at StdLib. We're fully FaaSlang compliant. We've created this standard. So you can go to StdLib.com, sign up. You don't actually have to sign up through the website. You can do everything through the command line tools. Our command line tools are available at github.com/stdlib/lib. It's a very simple npm install lib.cli-g to install our command line tools globally, and then lib create. So what I'd like to do, I wasn't quite sure if I'd have time, but I have about 6 minutes here. So what I'd like to do is actually try and show you guys a really quick demo of, let's see if I can get this. You can see everything? Cool. I want to show you guys a really quick demo of working with StdLib and FaaSlang here. So I'm in my StdLib workspace directory, which I basically just initialized with libinit. To tell my system that this is where I want all my StdLib functions stored. So to create a function, I can do something as simple as lib create. Make sure I'm online here. Okay. Oh. I do this demo a lot, so. Okay, let's create my service name testf. It knows I'm logged into the system as Keith, so it's going to automatically create this directory Keith/testf. I can just copy and paste this command. Go into this directory. Let's open this up and see what this looks like. Oh. Cool. So we actually have a really simple directory structure here. I'll just increase the size of the code so you can see it, maybe a little bit bigger. We have a few files here just to git ignore for, I anticipate many of you, or probably most of you, use Git as your version control system. Environment variables in env.json, a simple package JSON that tells us what to do with StdLib when we ship it, and a very simple main.js function. So this just says hello name. I can test this from my command line, so we have local testing enabled right out of the box. I can test this from my command line by just doing lib period. It's going to run that main function, _main, automatically. So hello world, because world is the default parameter. I can specify a parameter by just putting my name here, lib period Keith, hello Keith. I can actually, if I want to specify a named parameter, I can do name Keith as well. It's going to say hello Keith. If I want to see what's going on behind the scenes with the FaaSlang gateway, the actual execution gateway, we run a version of it locally. -D is for debug, so we can see the gateway spins up really quickly and executes the function and returns hello Keith. Now if I want to modify this, I can do add age equals, I'm 28 years old right now. Hello name, you are age years old. Okay, so if I try and execute this right off the bat, I have I'll just show you. I try and run this, and I actually get a function definition error. It won't let me run it. It won't let me try and upload this to the cloud. Commented parameters do not match my function footprint. Expected 1 parameter, actual parameters 2. So I can really easily here, at param number age, your age, run it. Hello world, you are 28 years old. Name Keith, age, now I'm 50. Hello Keith, you are 50 years old. And because we have default parameters in here, I can actually just specify age alone and say, hello world, you are 50 years old, because I have the default parameter name in here. Now if I want to upload this to the cloud, this is a very simple command, libupdev. Cool. And I get this URL, keith.lib.id/testf@dev. Awesome. Hello world, you're 28 years old. I can pass in parameters simply via, you can see I've done this a little bit. Jacob is my co-founder, so I'll put in Jacob's name here. Hello Jacob, you're 28 years old. So this is like any of you could open up your phone and go to this URL right now, and this would execute. It's not protected at this point. And if I try and put an invalid parameter, age equals XXX, I'm actually going to get an HTTP 400 error, bad request, and I get this standardized error type that says parameter error and gives you information that age is invalid value string, expected number. So it actually did automatic type coercion from the string parameters in the HTTP request. Cool. And that's a really, really high-level introduction to StdLib and how easy it is to ship code. To relate to that PHP automatic routing based on name. I'm just going to call this afunc.js and just say a function. I do libupdev again. So anything in that functions folder just turns into an endpoint, right? So then I see this afunc. I can use this URL. And just returns a function as a string. Now you can actually return like buffer and file data, so you can actually serve like full, fully functional websites using this as well. Very simply, I won't go through the whole deployment process again, though it is quite fast, by just doing new buffer string contents. You can put whatever you'd like in there. And that's how you return file data. I would obviously have to return this, change this to returns buffer. But yeah, if you'd like a more in-depth demo, we actually have something called the lib library. I was talking about the Node.js SDK, so you can do const lib equals require lib, have to npm install it, and then you can access any of your functions, testf in a development environment. I can actually just execute this as if it's, and it can receive a callback. So name hello, have a callback, and I can do anything I want in here. So integrating with other functions in StdLib that are published to StdLib are super easy, and if you want to connect this to other gateways, you can put in configuration parameters in your require. So if you're running your own FaaSlang instance or working with another host that's not StdLib, you can still connect and use these call signatures in the same way. So I recommend, if you're interested in checking this out, that you actually go to stdlib.com. We have a YouTube video of showing basic function composition and how you can use this lib library to essentially create actually pretty complex and cool scripts and applications in a really short amount of time. So with that, there we go. With that, just as a base recap, the technology over the past 20 years has basically come full circle. We've minimized shippable unit size with functions as a service. We've minimized shippable unit size while maximizing scalability. One of the function as a service value propositions is a fundamental increase in developer velocity. You'll hear a lot, especially if you're in a CIO or CTO position, about not risking over-provisioning or under-provisioning, and these are all super valuable. There are cost savings to be had, but the fundamental increase in developer velocity is our focus and what we're the most excited about. And this tooling is rapidly maturing and ready for production. In fact, we've helped developers ship. We're partnered with Slack. They're one of our investors. We've helped Slack developers ship thousands of Slack applications already, just based on webhooks, functions in response to events. So yeah, you can do a lot of cool stuff with this. And thank you for having me.